example, the SALAC arginine to proline data analysis. CoreFlow, as you have seen, it's a flexible playground for integration, analysis and modeling of complex biological data. Right now we will open the example that we started last time. It's in the mass spectrometry ownership section in the SILAC experiments project and in the arginine to proline conversion thread. We'll take this estimation from experimental data task. We'll open it, and we are going to duplicate it, so creating a new task in another tree of analysis. So we'll call this the ownership of the task. Adrian will use here examples for learning CoreFlow project, and we'll have an example here of arginine to proline conversion. Okay, and I changed the step number, so I'll say this is going to be the first step. The author, so I'll change the author to, by clicking here, we'll get a list, the table with all the authors that have been defined. I'll pick myself, and so this is going to be a new task, which is a clone of a previous task. I'm going to insert it. Now it's going to be inserted as a new record into the database. I'm going to close, go back, and if you can see here that by clicking on this small round icon, I can refresh the whole tree. After refreshing, we get the new entry that we just have defined, the new task number 1. I will say that this is not a final product, so maybe this particular icon is not the proper one. I'll try to pick another one, for example this one, which says under development. So this has been done. I'm going to update. This updates all the information that you see on the screen in the database. Most of the things are ready now for the next step. We discussed last time about this area, this playground, which treats database, which manages the database and pre-process. It's doing a pre-processing of the information that we need. Usually in the next section, the blue one here in this area, we use another language like R or BioPython to process the data that is produced here on the fly. Okay, I'll review this part. Clicking this button will open in a colored syntax editor, which is developed by some third parties. You can click there to get more details. So it's going to open the script in the language R. We showed last time that we can run R in here in the application server or on the internet, but we can do the same thing by running it locally. There are advantages and disadvantages for each case, but we can basically use the best features in our advantage. So I'm going to open RStudio. This is a local, this is an application that runs locally on my machine. I'm going to create a new file, an R script file, because the script that I showed was created in R. And I'm going to paste here the script that you have seen previously. So it's the same script, but running in a local environment. The most important element probably is to get the data that you have seen before, the data that sits on a table. So I'm going to open again our current analysis step and remind you that the data is sitting in a table, so we have to extract it first from the table. How do we do this? If we go back to the RStudio, we see that there is what we call an application programming interface to CoreFlow. This call API run DB script and custom analysis ID, it does exactly what it says. It's running a DB script associated to 929. We can verify very simple this by copying the URL, going back to our browser and typing it there. By clicking enter, we'll get all the values that are in that particular table. This is mostly as you can see, a text document that is very long. It has all the rows. There is a separation of the rows, but you cannot see it. Anyhow, a language like R can understand this very easily and can read it. So I can simply run the set of lines that you have seen before, and it's going to provide me in the output window in this console whatever happens at each step. For example, here I loaded the library, here I made a connection to the CoreFlow, I obtained the data, and I stored the data into a data frame. Of course, I can then visualize what is the structure of the data frame, and it tells me that it has this number of rows, and it has this particular content. So it has a sequence, which is a peptide, an experiment, or a sample number, and the ratio, heavy overlay that we discussed. So I can run everything here and obtain, for example, the final results. The final results are the estimation of arginine to proline conversion. And then, of course, I can draw some plots. For example, here is the language, or in the R language, how I can show a plot in a bar chart format. Basically like running everything else. So this is what I'm going to do. I'm going to run this particular function that is defined and everything else that is here, and I'll see what I can obtain in the end. You see at the bottom in the console the fact that something happens, and the data is processed and generated, and indeed here I have my plots. This is the last plot, and this is the first plot that was produced. The conversion rate is on the y-axis. Here's the sample or the experiment that I have provided, and as you can see, for a particular conversion of the arginine to proline, the green sticks are much higher, around 10%, conversion rate, but only for some samples. Some of the samples have been corrected by the biologists. The same result you have seen also by running our script here in on the application server on the internet server. Okay, so this concludes our second presentation. We have seen that we can run everything in our playgrounds. The only thing that is maybe missing right now is to show you how we can attach files. So such a result that you have, the one that you have seen, for example, by running this application, this script, and which is generated here, can be also attached to our task. Right now there is nothing here in the attachment section. We can attach any file we want by just choosing the file and entering the description, or we can meanwhile we can go back here, and by clicking this small icon it's going to attach the files, and I'm going to attach two files right now. This was the PDF, and this is somehow the history of everything that is reported by R on the server. Now I can go back to our analysis number 940. I can refresh because I have updated everything into the database, and here my files that have been attached. Going back and clicking on the refresh, I get the updates of the attached files and all the modifications. So we'll continue with maybe more about what is Arginin to proline conversion, and how and why is it important. Thank you, and bye for now.